Okay, so what we're going to do now is the momentum questions. I've got a couple here on the computer. It says 30 gram billiard ball with a velocity of 2 meters per second forward hits another ball of 35 grams that was at rest. If the second ball had a velocity of 1.5 meters per second forward, what is the velocity of the first ball? Okay. And so, first of all, we've got the mass 1 is 30, and mass 2 is 35 grams, and then velocity initial. I'll change this to A and this to B. Velocity initial A is 2, and let's see, velocity initial B is 0. Then it says if the second ball has a velocity of 1.5 meters per second forward after the collision, velocity final B is 1.5 meters per second. And we'll mark down forward. What is the velocity of the first ball? Velocity final A, question mark. Okay, and so I noticed that these are, this is an inelastic collision. Or sorry, an elastic collision, and so the actual equation goes like this: ma velocity initial A plus mb velocity initial B equals ma velocity final A plus mb velocity final B. And I'm basically solving for velocity final A, and so I pass this over that way, and I'm going to this is also forward too, by the way, up there, and velocity final A is what I'm trying to solve for. So I'll pass this over through subtraction, and I'll get MAVIA plus MBVIB minus MBVFB equals MAVFA. If I divide by MA, that's what I get. Okay, and velocity initial B is 0, so that term goes away, and so in the end it's just 30 times 2, which is forward as well, and then this one is forward as well. Since they're both forward, I can add them without being concerned about using a vector addition chart. And so it's really just 30 times 2 minus 35 times 1.5 divided by 30. Okay. There's that one. Now we'll move on. Here it says a toy rocket. Let me just zoom out a little bit. There we go. This is a toy rocket of mass 500. You can just kind of read that there. You can press pause and make sure you've got it. 500 grams has been shot in the air and has a velocity of 50 meters per second up. Okay, and so it looks like we've got some sort of initial velocity, and it's 50 meters per second up. When it suddenly explodes into two pieces, one piece 4 times more massive than the other. One piece is 4 times more massive than the other. My original mass is 500 grams. Then it explodes. If one piece is 4 times larger than the other, then we've got mass of A, mass of B. One is little and one is big. And if I just choose a couple of masses, then I think 100 and 400 would work, because in the end they both have to add up to 500. Okay, one way to figure that out would be to go, well, I've got one mass and I've got another mass, B, sorry, and it's equal to 500. Mass A plus mass B is equal to 500. Let me just write that a little more clearly. But then I also know that mass A and mass B have the following relationship, where mass A is equal to 4 times mass B. And so, since mass A is equal to this, I can just take this and put it into here, and I get 4mb plus mb is equal to 500. Now 4mb plus mb is 5mb. If I divide both sides by 5, I get mb is equal to 100. Okay? 100. And so, or MA is equal to 100. Either one. It doesn't matter which one you call A and which one you call B. It looks like the way I ended up doing it was a little different. So one of them is B, 400, and one is 500. Okay. And originally they're 500. And this is an explosion, so I get the explosion equation out. Okay. Oh, and by the way, it says that the final velocity of the larger piece, and so velocity final B, is equal to 30 meters per second at 30 degrees above horizontal. All right. And so I've got some information here. If I write down the explosion equation is essentially we have an original mass, which is MA plus MB usually. It's written as MA plus MB. That times the initial velocity is generally equal to the mass of one times its final velocity plus the mass of another times its final velocity. And so we've got all of this information, except we don't have final velocity A. And that's what we're actually looking for. Find the velocity of the smaller piece was the question, if you go back and look at that. And so we've got this situation here. Final velocity A. I'm looking for that. So what I'm going to do here is I'm going to subtract this over to here and say MOVI minus MB VFB equals MA VFA. All right, and so now I just simply plug some things in here. So MO is 500, and then initial velocity is 50 meters per second. This one's up. It looks like I'm going to have some problems here. MB is 400. And this is 30 meters per second. This is not up. This is at 30 degrees above horizon. So what I'm going to do here is I'm going to realize, okay, these are not in the same direction. Their angles are different. And so I'm going to have to go back and figure out what is up. Well, if I draw a side view, up can be considered at 90 degrees, according to my calculator. And 30 degrees above horizon can be considered at 30 degrees. So I'm going to write 90 here and 30 there. And this is equal to MA, which is 100 times VFA. And I'm actually looking for VFA. All right. Now, the problem is, well, it's not really a problem, but one of the issues is, well, one of the issues, I'm running out of space, but I've got a 500 times a 50 here. And so we're going to just figure that out. It's 25000 at 90 minus, and then 400 times 30 is 112000 at 30 degrees. And equals 100 VFA. And so in order to figure out these two things, I'm going to need to use the vector addition chart. And so I will go 2500 sine of 90 minus 1200 sine of 30, 2500 cosine of 90 minus 1200 cosine of 30. And this is going to be pretty simple here. It's 2500. Sine of 90 is 1. So it's 2500. Well, I'll just type it in just in case I get a wrong result. We don't want to do that on a video. Do that often enough. Let's go with 2500. Sine of 90 minus 12000 sine of 30, 19. And then, oops, actually I can just go up and do delete cosine. Minus, that looks like it doesn't work. 1200 cosine of 30. Let me just make sure that's right. 2500 cosine 90 minus 1200 cosine 30. Looks good. It's negative 10,392. And so I got 1900 squared plus 10,392 squared. So I'll take this number and I will second answer, square it, and I will add it to 19,000. Oops, that's multiplication. I need to add. There we go. That's a big number, and so I need to square root it. And I get 21,656. Okay. And probably just move straight down here. Different piece of paper. And so this is in meters per second. This is kilogram meters per second, by the way. And so, coming from here down, all right, and so I've got all of this is 21,656 kilogram meters per second, and its angle, and this is equal to 100 VFA, by the way. Its angle is tangent inverse of 19,000 divided by a negative 10,392. Bang, negative 61. I have to add 180 because the x value is negative. And I get 118 degrees. And now, to figure out VFA, I divide by 100. You don't divide the angle by 100, only the magnitude. So it's 216.56 meters per second at 118 degrees is equal to FA. Where did the kilograms go? Oh, actually, that wasn't kilograms. My mistake. That's always been just grams. Because this is 100 grams and 100 grams. And so it was grams meters per second. But now the grams cancel because I'm dividing by 100 grams. And so there's my final velocity, VFA. All right. And that makes a little bit of sense, just a little summary there. If it was going up, and then it exploded, the small or the large piece was at 30 degrees. The small piece was at 118 degrees. Sorry, that's not 118. 118 is like maybe right here. And this was going at 30 meters per second, whereas this one was going at 216, which is quick, you know, but it's a small piece. So the small pieces kind of go off fast and the big pieces go off a little slower. Anyway, that's the result. All right, that was a couple of momentum questions.